Hi, I'm Sergej. Welcome to the last talk of this session. So this is joint work with Dominik, Schürmann, Karoline, Busse, Yasemin, Sascha, and Matthew. And yeah, what we did in this paper is we did a short online study about the different textual fingerprint presentations. So let me start with a quote. So there was a short journal paper with some anecdotal evidence that users don't verify SSH keys. So the title is "Do Users Verify SSH Keys?" and the abstract is just consisting no, and that's it. So, but there was no study behind it, and also it was anecdotal evidence. So in the top right corner, you see like an example fingerprint of SSH, and when users connect to a server, they should verify whether they connected to the right server. And it is often claimed that, yeah, those are not checked and also error prone, because if we create like partial preimages where most of the characters are the same, but a few are different, the users wouldn't even notice. And also most of them are, yeah, it's also like, for the user, it's a cognitive load, it's hard to compare, and many people are saying like it's like meaningless comparison of characters, so that's why users are not even motivated. But somehow this is still relevant, because most of the messengers which implement like end-to-end security, like Signal or WhatsApp, they still rely on this technique. Because if we don't have a CA infrastructure, if we cannot implement a transparency directory, there is no other way to do the verification. So somehow we have to do it. So that's why we think that it is still relevant. So our goal is yeah, to study which of those textual representations are best. We are just testing the textual representations because, yeah, you could perhaps get a business card with someone's Pgp key on it, or yeah, your device is not supporting QR codes and so on. Yeah, so yeah, the best fingerprint representation would like produce a high attack detection. So if the user is exposed to partial pre-images, yeah, he should detect if there are some attacks going on, and also without producing a false positive rate for whatever reason. They also should be efficient. The user should compare them fast, and yeah, have a low cognitive load. And of course, we are interested in the user perception, because there might be some representations which are yeah, efficient and also have a high attack detection, but the user perceives them yeah, to be hard, and they also need to be robust. That means like if we want to make them accessible and so on. So what we tested in our initial study are those 6 approaches. So we took the hexadecimal, which is like the state of the art, as the baseline, because it is used by SSH and Pgp and so on. And we also compare it to base 32, because we talked to some users and they couldn't even distinguish the difference between hex and base 32, because for them it was just characters and numbers. We also compared this to a numeric approach, just where you have simple numbers from 0 to 8,100 and so on. So depending on which length you choose. Yeah, then there is also the Pgp Word List, which was developed by Phil Zimmerman, who wanted to use these comparisons via phone and chose 512 different words, and each, yeah, so the fingerprint is matched on the word list. So, and as you can see, there are also the examples how the word list looks like, except of that it consists of 16 words rather than 4, and all the fingerprints are longer. This is just to show how they look like. But there is also the Empirical word list, which consists like about 16,000 different words. So it's a huge dictionary which was derived from the most common words in movie subtitles, minus offensive words and so on. And there are also different sentence generators. We took one example, which is described in more detail in the paper, which produces grammatically correct sentences, but semantically they just don't make sense, so as in this example. Yeah, so our threat model, how we produced or did the preimage attack. So the ideal attack would be for an existing key fingerprint, we find a preimage, and yeah, this is mostly not possible for most of the hashing algorithm because it would be first too expensive, but also like infeasible if it's long enough. And yeah, there are workarounds, so we generate a partial preimage, so the fingerprints almost match except of a few characters, and this would exploit people's attention limitations. So we assume that the people wouldn't check it fully concentrated. So, and here we have to choose like the attacker strength. And yeah, we have a few assumptions. So the fingerprint is derived from the actual public key which is used in some metadata, like the creation date, like it is the case in OpenPGP. So this is why we don't have to generate a new key every time. It's just enough to change parts of the metadata, like the creation date, which is also part of the fingerprint. We would increase the time and so on. So in this case, we just assume that this hashing algorithm needs to be performed. And also with some key stretching techniques, we could make also the fingerprint a bit shorter. So if we would take a 160-bit fingerprint and use a script on it, and then truncate it to 112-bit, the users would get shorter fingerprints, and our attacker is controlling 80 of those 112 bits. So that basically means 80 bits are the same, which is still a high cost to generate those partial preimages, but it's not impossible. So when we do those attacks, we basically have controlled and uncontrolled bits, and the bits which are uncontrolled are just inverted. So in this case, we don't even try to find the key or to find the correct key with the fingerprint. We just take the fingerprint and change a few bits where we just simulate the attack. And the inversions are taking place only within logical sequences. So if we have an alphanumeric approach, we just change a few characters, or if we have a word approach, we change all the bits inside of words, like to maximize the controlled characters. So this would be an example like for the hex approach, where we changed 8 characters. So the study design was then done on mTurk, and this was done like with a controlled experiment where the user had to perform a task and to test those fingerprint algorithms. And then this was followed by a survey where we asked the user for usability feedback, what he thinks about those approaches and so on. And so the main task is basically users have to compare fingerprints, and they just get 2 fingerprints and say whether they match or don't match. And after performing all the tasks, they are asked to fill in a survey where we ask usability questions and get some more feedback. And before actually starting with a real study, we started a few pre-studies to find out which parameters, which approaches we take. And in the end, we came up with a factorial design where we tested 4 different schemes. With schemes, it's mean like hex and base 32 are both alphanumeric, and in our pre-study we found out that the users couldn't distinguish between hex or base 32 or whatever. That's why they either got hex or base 32 but never had to perform both. And then when we asked in the survey, they didn't have to distinguish between those approaches, but they also had to do the numeric. And also for the word list approaches, they sometimes didn't even notice that some were generated words or the amount of words was shorter than in the other approach. And the generated sentences. That means that each user had to do a test like for one alphanumeric approach, for one numeric, one word list approach, and the sentence approach. So during that task, they just got a web page where they had a phone on the left showing the fingerprints and a business card on the right, which is the case with PGP sometimes. And they just have to check whether the security code is the same on the left as on the right, and just simply say whether it matches or doesn't match, and simply click on the buttons in the phone. So more details about our study design is, so they basically had to do 40 comparisons, which were counted in our case in a randomized order. So they could get hex or the other approach in the beginning and just had to do 40 approaches. And this randomized order is like minimizing the fatigue and learning effects. And for each of the schemes, we do exactly one attack with those 80, where the attacker is controlling 80 bits. So, and also we found out in our pre-study that if we attack like every second time, the users notice it quite well, and the accuracy is getting better. And that's why we would need more participants. That's why we just do one attack per approach. We also added a few 2 attention tests with obvious mismatches. So we show on the left like just 0, and on the right we show words which is obviously wrong, and users who are clicking on match on that, they fail the attention test and are excluded from the statistics. And we also provided a few training sets for each scheme. So before actually starting the study, we show how they have to do, and we added those training sets based on the feedback that in the pre-study, some people were starting to search for typos in words, and we're not sure, and we said during the training sets that they don't have to search for typos in the words. But those training sets were not considered in the results, how long they took to click. So after that, the users got a survey where we asked for some demographics and to rate the schemes, and they were asked several questions, something like whether the comparisons with this method were easy, and then they had to rate it for each of the approaches, where we remind them by showing it in the brackets how it looks like. So the challenges we had during the study is that we required a high number of participants and would need a lot of money, because we found out that the users are quite well in comparing things, and most of the users on mTurk actually did a good job in comparing it. So, and there were not that big differences between the approaches. And also, we could not test each possible parameter, so some of the approaches could use different chunk sizes or different colors or different font settings, and it would cost too much money. Such study would cost too much money to test all the different parameters. So we added an additional experiment where we just tested the chunking, but the same could be done with different font settings and so on. So we used the same font settings and the same chunking approaches for all of the approaches. So our results were in the end, like, we had 1,047 participants who were participating in this study, and 46 were excluded because they just randomly clicked somewhere and failed the attention tests. It was, in general, a mixed demographic, so there was a similar amount of males and females, and the thing in the demographics has shown that there is no real difference based on age, gender, or education, so it was quite similar. And as I said, there is a relatively high attack detection rate for our chosen attacker for all schemes. So in the experiment results, we see the speed in seconds. As you can see, the best approach and the worst approach are not that far away in the median. The more important column in this case is the undetected attacks, so how many attacks were performed successfully. And as you can see here, hexadecimal, which is like the state of the art, had 10% undetected attacks. So of all attacks happened, 10% were not detected. If we compare it to the language-based approaches like sentences or the Empirical Word List, which are lower. And the Empirical Word List was the fastest to compare. This is based on the fact that they had a large dictionary and the users had just to read 9 words. And then there is also a false positive column. And here we see like a different number in the sentences. That's because the phone was in the vertical, so not landscape. So the phone was vertical and the business card was landscape. And there were different alignments for some sentences which were longer. And that's when the users clicked, oh, it's wrong, even though the sentences were exactly the same. I don't have an explanation why base 32 produced more false positives than any other approaches, even though O and 0 are not inside. So there is no O and no I to avoid a confusion between O and 0 and 1 and I. In the chunking experiments, we tested the different chunking approaches, and we didn't get any significant numbers. So even though there are small differences in undetected attacks, those are not significant. The only thing which is significant is the speed, but it's quite similar for all chunkings. So hex 2 means like in 2 characters, like it is done in SSH, hex 3 in 3 characters, hex 4, and so on. As you can see, there is not too much difference in here. And in the survey results at the end, we asked them a few questions about the trustworthiness. That was like, do you believe such system is secure? And unsurprisingly, the hex and the base 32, because it looks like very random, most of the people said they believe it's more secure compared to generated sentences, even though those the security is the same. And regarding the usability, the language-based approach had a better rating. But here, as you can see, the differences are not that far away. We got a general feedback that most of the users were annoyed to do this task with any of the fingerprints. So even though they liked the generated sentences more, they still would rather skip it. And the limitations are like, as I said, there is no guarantee that the easiest approach will still lead that the users will actually do the fingerprints. And also there are some validity questions about MTurk, as with any MTurk studies, because the people have more experience or are more technical persons compared to the average population, and is also younger, and is in general used to visual and textual tasks. So because they do it a lot of tasks like this, And as I said, we didn't test all the different parameters because otherwise we would have too many conditions to test, and this would be too expensive. So to conclude my talk, yeah, as we can see, the hexadecimal approach, even though it is the state of the art, has shown the worst performance of all approaches. It has a lower attack detection rate, is also slower than most of the other approaches, and is perceived to be more annoying by most of the users. And the generated sentences produce the best result because yeah, they have the highest detection rate, and the users perceive it to be more usable. And numeric was the best approach without the language-based system, so in that case, WhatsApp did the right choice in their implementation. Actually, we didn't know that WhatsApp will actually implement it, so when we submitted the paper, this was a few weeks earlier than the announcement of WhatsApp that they are using these fingerprint methods. So yeah, that's it. And yeah, I'm happy to answer your questions.
We have time for questions.
Thank you for your talk. Brief question on open SSH keys. There is this option that you can activate that will show you a sort of ASCII graphics.
Yeah.
When you log into an SSH server, you didn't look into this, like why and
we
what do you
just
think
did
of
the
it?
textual approaches. So,
oh yeah, I already forgot the title of the talk.
So the thing is that yeah, it is first of all harder to generate like the attacks on this
yes.
Visual fingerprints, and second of all, yeah, there are people with visual impairment which probably cannot see this ASCII art thing. That's why we said we are just focusing on the textual approaches, and the textual approaches are also more robust in that sense that you can compare them via phone and so on.
Thank you.
Hi, Tabish there from Georgetown. I just had a quick question about the Empiric. So you showed a screenshot of the study. So was the phone image rendered, or was it just text on both sides? Because if it was text...
Oh, no, it was not text. It was rendered that they couldn't just copy-paste and do it automatically or something.
Okay. And another quick question. So for the Empiric study, usually the aim of the people is to just more task and get more money. So did you give any reward or any like more money to the people who guessed it right, so they had a motivation to do the study right instead of just clicking yes, no, yes, no?
Yeah, we didn't do that because in the real world, people are not motivated to do this on WhatsApp either. Okay. So that's why we wanted to make it like more comparable. Yeah. But
okay, thank you.
All right, so if we don't have any more questions, why don't we thank all the speakers again from the session.